Lesson for today is all about radicals. In this expression, and root of a, where a, the number of a is the radicand, and the square root sign is the radical sign, and the number n is called the index, and the entire expressions is called radicals. Today we're going to tackle about square root, or the use of how to simplify or how to illustrate if a square root of a is equal to b, then b squared is equal to a. That is quantity of square root of a to the second power is equal to a. If cube root of a is equal to b, then b cube of a, b cube is equal to a, or quantity of cube root of a raised to the power of 3 is equal to a. Remember that the radical sign implies the principal roots, which always positive, and the value of the variables is either negative or positive. Then we have to simplify the corresponding roots. Let's illustrate square root of 16 is equal to 4, since 4 squared is equal to 16. And the fifth root of 1 over 32 is equal to 1/2. Since 1/2 to the fifth power is equal to 1 over 32. And the cube root of negative 8 is equal to negative 2, since negative 2 to the third power is equal to negative 8. Now removing the n powers from the radical, which is fifth root of x raised to the power of 7, simply we can factors. The radical expressions can be simplified whenever the factors of the expressions under the radical sign can be grouped into a perfect root, which can be rolled out from the radical sign. So we can roll out x to the fifth power, that is being factored, cancel out 5, and the remaining is x times fifth root of x squared, and this is the answer. Because in exponential form, x cubed over 3, where the index is 3 and the radicand, powers of the radicand is 3, therefore cancel out. So the answer is x. In this we can relate the equations. How can we write exponential expressions such as b m to the n over n in the radical form, use the denominator n as the index of the radical and the numerator m as the power of the radicand or as the power of the radical. Like for example, and b raised to the power of m over n is equal to the quantity of nth root of b raised to the power of m. Remember the radical, and these expressions use the denominator as the index, where is 3. So cube root of 5x, cube root of 5xy to the power of 2, where is the numerator. In these expressions, we can simplify radicals. Cube root of 320, since 320 is not a perfect root of 3, we can factor first. Cube root of 64 times 5 is equal to 320. And then we factor again 64. 64 is the perfect root of 3, which is 4 times 4 is equal to 16 times 4 is equal to 64. Let's see, we have bin 3. By using the prime factors, we can use the bin 3. So 4 cube is equal to 64. Therefore, our factor is 4 cube times 5 and we can separate into groupings, which is cube root of 4 to the third power times cube root of 5. Then cancelled out 3, rolled out the numbers under the radical sign, which is 4. Since 3 over 3 is equal to 4, so we can cancel out, rolled out under the radical sign. So we can have 4 cube root of 5. This is the answer. And let's have another. We can tackle the laws of radicals. In the laws of radicals, nth root of a, b were separate into groupings of nth root of a times nth root of b, where the product multiplying an important use of product roll in the simplifying radicals with no perfect square factors remains under the radical sign. Like for example, square root of 50. Square root of 50 is not a perfect root, so we can factor first by square root of 25 times 2, and we separate into groupings, which is the square root of 25 times square root into square root of 2. Since 25 is the perfect root of is the perfect root. Therefore, square root of 25 is 5 and remains square root of 2, and this is the answer. Let's have another example. Is square root of 20 is equal to, we can factor first by grouping into perfect square, which is the square root of 4 times 5 is equal to 20. Then we can separate into groupings. Square root of 4 times is square root of 5. Where 4 is the perfect root of 2 and remains square root of 5, and this is the answer. And let's have the laws of radicals number 2, which is nth root of a over b is equal to, we can separate into each numerator and denominator by nth root of a over nth root of b. And these expressions, like the same as the product, it's this quotient we call the division process. Example, the cube root of 5 over 8, then separate into groups. Cube root of 8, since cube root of 5 is not a perfect root, but the cube root of 8 is a perfect root, so we can have 3 square root of 5 over the square root of cube root of 8 is equal to 2, because 2 times 2 times 2 is equal to 8, and this is the answer. Let's have another example, square root of 16 over 4, where we can separate into groupings numerator and denominator by square root of 16 over square root of 4, where square root of 16 is the perfect root of 4, where 4, since 4 squared is equal to 16, so we can put 4 over 2, because 2 times 2 is equal to 4, and 4 divided by 2 is equal to 2, and this is the answer. And let's have the laws of radicals number 3. Mth root times nth root of a is equal to m times n of a. These expressions, we can use the product and the quotients of both quotients and product are simplified and combined together. Let's have example, square root times the square root cube root of 64, where 2 times 3 is equal to 6. Then 2 times 3 is equal to 6. 6 are our index, and the radicand is 2 to the 6th power, because 2 times 2 times 2 times 2, 2 to the 6th power is 64. And we can roll out under the denominator, which is 2, and this is the answer. Bye bye.